Now, let's look at example 2. Show that tan 22.5 degree equals to root 2 minus 1. Solution. Tan 45 degree can be written as tan 22.5 plus tan 22.5 divided by 1 minus tan square 22.5 degree. Of course, this is obtained using tan A equals to 2t over 1 minus t square, where tan A equals to tan 45, and that gives 1. And t is taken as tan A over 2. A over 2, that is 45 divided by 2, that gives tan 22.5 degree, which is still represented by letter T. So tan 45, which is 1 equals to 2t divided by 1 minus t square. So when you cross multiply, I have t squared plus 2t minus 1 equals to 0. Using quadratic formula, a is 1, b is 2, c is minus 1. And t gives minus b plus or minus root b squared minus 4ac divided by 2a. And of course, t equals to minus 2 plus or minus root 4 plus 4 divided by 2. Square root of 8 is 2 root 2. And that gives minus 2 plus 2 root 2 divided by 2. And when you simplify that, dividing through by 2, I have t equals to minus 1 plus or minus root 2. The answer is t equals to root 2 minus 1. We have two answers there, minus 1 plus root 2 and minus 1 minus root 2. Of course, tan 22.5 degree cannot be negative, so we'll pick the positive value, t equals to root 2 minus 1. Example 3, show that sine 2 theta divided by 1 plus cos 2 theta equals to tan theta. Now, using the left hand side, sine 2 theta is 2 sine theta cos theta divided by 1 plus cos 2 theta is 2 cos square theta minus 1. And when you simplify that, you have 2 sine theta cos theta divided by 2 cos square theta. Of course, cos theta will cancel cos theta, 2 will cancel 2, then you have sine theta divided by cos theta, which is tan theta. That's the right hand side. So let's look at the next page, page 32. On page 32, we have example 4. Prove that cos 4th A minus sine 4th A equals to cos 2A. Cos 4th A minus sine 4th A equals to cos 2A. Left hand side, cos 4th A minus sine 4th A equals to, can be written as cos square A minus sine square A into cos square A plus sine square A. Of course, difference of 2 square. A square minus B square can be written as A minus B into A plus B. Now, cos square A plus sine square A is 1. So we are left with cos square A minus sine square A. And that gives cos 2A, which is the right hand side. And since cos square A plus sine square A is 1, now you have the following assignment. Yeah, to show that if tan theta is 4 over 3, calculate the possible value of tan theta over 2. If tan theta is 4 over 3, calculate the possible value of tan theta over 2. 2, show that sin 2a over 1 minus cos 2a is cos a. 3, tan 2 theta minus tan theta equals to tan theta sec 2 theta. And 4, 1 plus cos x plus cos 2x divided by sin x plus sin 2x equals to cot x. 5, tan square pi over 4 minus theta over 2 equals to 1 minus sin theta divided by 1 plus sin theta. And 6, 1 plus tan square a divided by 1 plus tan a all square equals to 1 over 1 divided by 1 plus sin 2a. Now let's look at page 33, the factor formulae. The factor formulae, sin a plus b, we'll record as sin a plus b equals to sin a cos b plus cos a sin b. And sin a minus b equals to sin a sin a plus b equals to sin a cos b plus cos a sin b. And sin a minus b equals to sin a cos b minus cos a sin b. On adding, we have 2 sin a cos b. The right hand side gives 2 sin a cos b. Then we have that gives sin a plus b plus sin a minus b. And on subtraction, when you subtract, we have 2 cos a sin b. Of course, if you subtract, we have 2 cos a sin b, the right hand side, minus, we cancel minus, then you have cos a sine b plus cos A sine B. That gives 2 cos A sine B. Then we have on the other side, you have sine A plus B minus sine A plus B minus sine A minus B. Similarly, for the cos, 2 cos A cos B gives cos A plus B plus cos A minus B, and 2 sine A sine B gives cos A minus B minus cos A plus B. If you put A plus B equals to C and A minus B equals to D, so that A equals to half into C plus D and B equals to half into C minus D, sine C plus D equals to 2 sine half C plus D cos half C minus D, and of course sine C minus sine D equals to 2 cos half C plus D sine half C minus D. Similarly, cos C plus cos D equals to 2 cos half C plus D cos half C minus D, and cos C minus cos D, take note, we have minus 2 sine half C plus D sine half C minus D. This formula enable us to express a sum or a difference of 2 sines or cosine as a product. Note the minus sign in the last result. The formula is easier to remember if you take cos sine sine. If you have sine sine, then you have sine cos. If you have cos cos, you have cos cos or sine sine. Take note, sine C plus sine D will give us sine cos, sine C minus sine D will give us cos sine, and cos C plus cos D will give us cos cos, cos C minus cos D will give us sine sine. Now let's look at page 34. Page 34. On page 34, example 1, show that sine 50 degree plus sine 40 degree equals to root 2 cos 5 degree, and 2 cos 70 degree plus cos 20 degree equals to root 2 cos 25 degree. Now the solution, using sine C plus sine D equals to 2 sine half C plus D cos half C minus D. C is taken as 50 degree, D is taken as 40 degree. Now substituting on the right hand side, sine 50 plus sine 40 equals to 2 sine half 50 plus 40 cos half into 50 minus 40, and that gives sine 90 degree over 2 cos 10 degree divided by 2, that is 5. 90 over 2 is 45, and sine 45 is root 2 over 2 multiplied by 2, that gives root 2 cos 5 degree, and that's what we have to show. In 2, using cos C plus cos D equals to 2 cos half C plus D cos half C minus D. C, of course, is 70 degree and D is 20 degree. Substituting, I have 2 cos half into 70 plus 20 cos half into 70 minus 20, and that gives cos 90 divided by 2 is 45. That's giving root 2 over 2 times 2, then 50 divided by 2 is 25. So I have root 2 cos 25 degree. And of course, on page 35, let's look at page 35. On page 35, example 2. On page 5, example 2, show that sine 2a cos 4a plus sine 3a cos 9a equals to half sine 12a minus sine 2a. Now, using the right hand side, sine 2a cos 4a equals to half sine 2a plus 4a plus half sine 2a minus 4a. And that reduces to half sine 6a, 2 plus 4 is 6, half plus half sine 2 minus 2 minus 4, that gives minus 2. So I have sine 6a plus half sine minus 2a. Of course, sine minus 2a is minus half sine 2a. Half sine minus 2a is the same thing as minus half sine 2a. Let's call that equation 1. Similarly, cos sine 3a cos 9a. Sine 3a cos 9a is half sine 3a plus 9a plus half sine 3a minus 9a. And that reduces to half sine 12a. 3 plus 9 is 12. 3 minus 9 is 6. And that gives minus half sine 6a. Equation 2. Adding equation 1 and 2, then we have sine 2a cos 4a plus sine 3a cos 9a gives half sine 12a minus sine 2a as required. Now, example 3, express sine 4x cos 3x as the sum of difference of sine or cosine. The solution, sine 4x cos 3x can be written as half into, of course, using the formula 2 sine a cos b equals to, or 2 sine, using the formula. Let's look at the formula we use there, sine cosine. So 2 sine a cos b gives cos, I'm using the formula for 2 sine a cos b to give sine a plus b plus sine a minus b. And of course, I can take the 2, this 2, I can take it to the other side, and I have sine a cos b to give half sine a plus b plus sine a minus b. So in that question, express sine 4x cos 3x as the sum of or difference of sine or cosine. Sine 4x cos 3x can be written as half into sine 4x plus 3x plus sine 4x minus 3x. 4 plus 3 is 7. 4 minus 3 is x. 4x minus 3x is x. So that solution is half sine 7x plus sine x. Half into sine 7x plus sine x. And of course, the next page, let's look at the next page. You are given the following assignment. Express as sum or difference. 1 sine 70 cos 2t, 2 cos 8x sine 2x, and of course we have the following: 2 sine 70 sine 3t, 4 3 sine pi over 3 cos pi over x, and the others follows. So let's look at the next page, page 37. The next page, page 37, the function a cos theta plus b sin theta, written in the form r sin theta plus or minus alpha, or r cos theta plus or minus alpha. Let a cos theta plus b sin theta equals to r sin theta plus alpha. Let a cos theta plus b sin theta equals to r sin theta plus alpha. And of course, r cos alpha r and alpha can be found by the following reasoning: r sin theta cos alpha plus or minus r sin theta cos alpha plus or minus r cos theta sin alpha is same thing as r sin theta plus alpha. If we expand r sin theta plus alpha, then comparing the left hand side with the right hand side, comparing a cos theta plus b sin theta with r sin theta cos alpha plus r cos theta sin alpha. R cos alpha is b and r sin alpha is a. If we square and add these equations, I will have r square into cos square alpha plus sin square alpha equals to a square plus b square. And of course, cos square alpha plus sin square alpha is 1. R equals to root a square plus b square. On division, r sin alpha divided by r cos alpha equals to a over b. Tan alpha equals to a. Tan alpha equals to a over b. Tan alpha equals to a over b. Alpha is tan inverse a over b. So this implies that a cos theta plus b sin theta is same thing as root a square plus b square sin theta plus alpha. Alternatively, we could set a cos theta plus b sin theta to be r cos theta minus alpha if we don't want to use r sin theta plus alpha. So, and if we expand the right hand side, I have r cos theta cos alpha plus r sin theta sin alpha. R cos alpha is a, r sin alpha is b. Then the next page, page 38, that gives, on squaring and adding, r is same thing as root a square plus b, and on dividing, tan alpha equals to b over a. A cos theta plus b sin theta is root a square plus b square cos theta minus alpha, where tan alpha in this case will be b over a. Now example 1, express in the form r sin theta plus alpha, the expression 2 cos theta plus 3 sin theta. If we let a to be 2 and b to be 3, our r is simply root a square plus b square. Our r is root a square plus b square. So 2 cos theta plus r sin theta can be written as root 2 square plus 3 square sin theta plus alpha. And of course, tan alpha is a over b, which is 2 over 3 Sin alpha can also be written as r over a over r, and a is 2, our r is root 13. Cos alpha can be written as b over root r. Cos alpha can be written as b over r, and our b is 3 and our r is root 13. So alpha is an acute angle. Because if you look at a and b, they are all positive. So which sin alpha is 2 over 3 is 2 over root 13 is positive. Cos alpha, which is 3 over root 13, is also positive. So it shows that alpha is an acute angle. From table, alpha, if we use, we can pick any one of them. So alpha will give us 33 degrees 41 minutes. So 2 cos theta plus 3 sin theta is root 13 sin theta plus 33 degrees 41 minutes. Now let's look at the next example on page 39. On page 39, I have expressed in the form r cos theta minus alpha 2 cos theta minus 2 sin theta. Of course, cos theta minus 2 sin theta is root 1 square plus 2 square. A is 1, b is taken as 2 cos theta minus alpha. So in this case, tan alpha is minus 2 over 1, which is minus 2. Sin alpha is minus 2 over 5, cos alpha is 1 over 5, so that our alpha lies in the fourth quadrant. Alpha lies in the fourth quadrant. So from table, tan minus 2 is same thing as minus 63 degrees 26 minutes, because it's in the fourth quadrant. So cos theta minus 2 sin theta is root 5 cos theta minus into minus 63 degrees 26 minutes, and that gives root 5 cos theta plus 63 degrees 26 minutes. So these two can be taken as assignment. Express 3 cos theta minus 4 sin theta in the form r cos theta plus alpha, and 2 express 3 cos theta plus 2 plus 4 sin 2 theta in the form r sin 2 theta plus alpha, and state the maximum value of 3 cos 2 theta plus 4 sin 2 theta. Now let's look at the next page, which is on page 40. Page 40. So we have to solve the equation 3 cos theta minus 4 sin theta equals to minus 2.5. Solve the equation 3 cos theta minus 4 sin theta equals to minus 2.5. Now the solution, we want to express the left hand side 3 cos theta minus 4 sin theta in the form of r cos theta plus alpha. We want to express 3 cos theta minus 4 sin theta in the form of r cos theta plus alpha. Our r, of course, is root a square plus b square. A is 3 and b is 4. So the right hand side could also be written as root that equation r cos theta plus alpha. We can expand it as root 3 square plus 4 square into cos theta cos alpha. Cos theta plus alpha, I want to re-express it as cos theta cos alpha minus sin theta sin alpha. And of course, our tan alpha will be 4 over 3. Alpha is tan inverse 4 over 3, which is 53 degrees 8 minutes. So r, we know r to be root 9 plus 16, which is root 25, that is 5. So 5 cos theta plus 53 degrees 8 minutes equals to minus 2.5. So the left hand side, r cos theta minus 4 sin theta, can be written as 5 cos theta plus 53 degrees 8 minutes equals to minus 2.5. So if I divide through by 5, cos theta plus 53 degrees 8 minutes is same thing as minus 1 over 2. That is minus 2.5 divided by 5 is minus 1 over 2. That is 0.5. 0.5 is the same thing as half. And because of that minus, we have minus 1 over 2. So taking cos inverse of minus 1 over 2, I have 120 degrees because it's negative. That negative means that the angle is in the second quadrant. It's in second quadrant. So alpha is cos inverse minus half, which is 120 degrees for that right hand side. And of course, the left hand side, theta plus 53 degrees 8 minutes. If we use the general formula, general formula for cosine, cos of angles. The general formula for cos of angle is n 360 degree plus or minus alpha. So we can take the 53 degree 8 minutes to the other side. Our theta is n 360 degree plus 120 minus 53 degree 8 minutes, which is 66 degree 52 minutes. So it's going to be plus or minus, or theta is n 360 degree minus 173 degree. And that's the solution. We can get the value of theta by substituting for the value of n when n is 0, when n is plus or minus 1 or plus or minus 2, and so on. So it depends on the range that is given in the question that will determine where to stop. Now the second method for tackling the problem, let tan theta over 2 be t, and cos theta, of course, using the half angle formula, cos theta is 1 minus t square over 1 plus t square, and sin theta is 2t over 1 plus t square. So substituting in the formula, in the expression 3 cos theta minus 4 sin theta, so I will have on page 41, of course, on that page 41, so I have 3 1 minus t square divided by 1 plus t square equals to 4 minus 2t over 1 plus t square, which is the right hand side, minus 2.5. So cross multiplying and collecting like times, I have t square plus 16t minus 16 equals to 0. Of course, I can multiply through by 2 to cancel the decimal there. So when t, our a is 1, our b is 16, and our c, which is 16, so substituting into that formula, minus b plus or minus root b square minus 4ac all over 2a. So I have t to be minus 16 plus or minus root 300 over 2. So when you simplify that, I have t equals to minus 16 plus or minus 17.321 divided by 2. So t is tan theta over 2, and that gives 0.660 or minus 16.660. So that gives theta over 2 is using the general formula for tan. So n 180 degree plus or minus 33 degree 26 minutes, or theta over 2 equals to n 180 degree minus 86.34 minutes. How did they get 33.26 and the other 86.34? So is to take tan inverse of 0.660 or tan inverse of minus 16.6605. So theta will now give us, when you multiply through by 2, n 360 degree, theta equals to n 360 degree plus 66 degree 52 minutes, or theta equals to n 360 degree minus 173 degree 8 minutes. So as before. So the assignment will be find the general solution together with all solution in the range of 0 degree less than equal to theta, theta less than equal to 360 degree of the equation 1. 2 cos theta plus sin theta is 1. 2 sin 3x minus cos 3x is 1 equals to 1. And 3 24 cos x minus 7 sin x equals to 12.5.